Hi everyone, in today's video we will learn about the first step in applying any natural language processing technique and the most important one, text processing. This video will cover the theoretical part and the next video will have the coding part. This is the content for today's video. We will go over the basic framework, different types of data retrieval, what is text processing, and what exactly we need to remove or convert in text data. Please check our reference for more information. When we are doing data analysis, we need to go over some steps. This basic framework is specifically for text data, but most of the steps are the same for other types of data as well. We first go over the problem statement. We need to define what is our problem and what we want to achieve after we go over all the other steps. We need to define what is our end goal, what outcomes are we expecting. Do we have some specific problem that we want to solve, or it's something generic? We need to define this in the beginning of the process, otherwise we won't be able to continue it. The step 2 is the data collection process. It is when you are out in the field collecting data or using an API for collecting tweets, for example. Usually, this step is needed when you are designing your own experiment and has ways to collect the data by yourself or to supervise the collection. In our case, we will not collect the data because someone else already collected the data from Reddit and made it available. So we will only retrieve the data. And that's step 3. In this step, we will retrieve the data from some database. In our case, we will retrieve from MongoDB using Studio 3T. Step 4 is the text processing. This step is specifically for text data, and for other types of data, we can call it simple data processing. Text data should not be used without text processing because that use leads to unsatisfactory results, and in the end, we won't be able to achieve the goal that we stated on step 1. Step 5 is the application of techniques. We apply the technique we need. For example, we can apply word embedding technique, word2vec, or a top modeling technique. And step 6 is the machine learning algorithm. If we need, we can apply a machine learning algorithm depending on the outcome we expect. Step 5 and 6 are known as model building. Step 7 is the analysis of the results obtained from the applied model. We need to evaluate the model and see if it delivered what we expected and what exactly we stated in step 1 is being achieved for the model we built or not. We need to assess that during step 7. This whole process needs constant feedback, so any error that occurs can be easily fixed before the next step. Otherwise, we will get to the end analyzing our results and see that everything is wrong and we didn't notice that there were some errors in step 4, the text processing step. Data can be retrieved from different sources and in different formats. Some of them are APIs. The tweets from Twitter are retrieved using APIs. We can retrieve data from databases. And we can have different formats like PDF, Word documents, websites, JSON objects, .csv files, .text, everything. So in our case, our data is retrieved from the Reddit database using Studio 3T, and our data is exported to a .csv file. So we're going to use .csv files in our analysis. So what exactly do we want to do with the text? We want to transform this text from our language to a pre-processed format that will be used to generate vectors that we can apply math and do calculations. For example, we have two phrases here. The mouse ran up the clock and the mouse ran down. They share some words in their composition, right? So those phrases will be our input, and we will process the text, and the embedding function will perform some calculations to transform each word in a vector. The embedding layer has 4 dimensions. That means that the vectors generated by this embedding function has 4 dimensions. If you notice, the vector generated for the word mouse, the second of each block, is the same for both phrases. So in this case, we have the phrase, both phrases, we input in an embedding function or in our algorithm, and this will do a transformation that will output an vector. In this case, we have a vector with 4 dimensions, but we can choose up to thousands of dimensions. But each dimension that we include, it means that will be a larger vector and it will also be computational expensive. A text consists of more than just letters or words. In this example, we can see words, numbers, and different symbols. Those are all parts of a text. Here, we will introduce a new word that we will use throughout this course. Corpus is a collection of written text. Any text can be called a corpus in our context. So when we say that we're going to go over a corpus, means that we're going to go over a text. Like I said before, text processing is the first step of the analysis when we are analyzing text data. This is equivalent to data processing in other types of data. And we can see here, after we apply text processing, we have a smaller text because we took out everything that was noise and we do not need for our analysis. And what is text processing? So text processing is the automated process of analyzing text data for getting structured information. So we don't want a mess in our text. We want something structured with information that we can understand and the computer can understand and give us exactly what we need. In our case, we will remove everything that will not contribute to a better understanding of our data. That's our text processing. We will go over some of the necessary features to remove or convert from a text in this part, but they do not have to be executed in this specific order while we are coding. Some of them have some specific order and we're going to talk about it, but usually they can be changed and it will not implicate in the outcome result being different. So we must remove, the first thing is we must remove white spaces. Any extra space in the text, it is not the space between words or space between phrases and paragraphs, or when we have more than one space between any text part. If I have 2 spaces between 2 words, we're going to remove one of them. Punctuation must be removed because they are noisy, and when included in the text, they do not provide any insights about the data. Usually, they don't help at all. So special characters are the characters like hashtag marks, percentages sign, and they can be removed with the punctuations or separately, but they must be removed. Accent marks are more common in other languages than in English, but sometimes they appear and they should be removed because they do not help us in anything, and not even to understand the words. So we usually just remove them because they are just noise data. Emojis are usually removed from the text, but depending on the analysis that you are doing, they can be left inside the text. However, it is better if you remove them or at least extract them to another column of the database, the data set, because in that way you can use them for another type of analysis. But usually the text processing part or to generate word embeddings, we can generate a word embedding for an emoji, for example. And even if we do, it's not very meaningful. So we usually remove the emojis or we put them in another column of the data frame. And if we are using like sentiment analysis and we can use the emojis, we will have to do another type of algorithm to deal with it. The next thing is the emails. We have to remove emails because they do not provide any insight about the text. They are usually non-important data, non-important information. And however, if you need The same thing that I said for the emojis. If you need the email, you can just put that information in another column of the data frame and use it later. But we have to remove it from our data set, like from our comments, because they are just noisy. And an important thing is that we have to remove the emails before removing the special characters. And why is that? Because if you remove the special character at before you remove the email, you will not have an email anymore to remove. So if you remove the at from the soil@hotmail.com, you will not have soil@hotmail.com. You're going to have soil@hotmail.com. And later on, we will not recognize this as an email. So we won't be able to remove the email after we remove the special characters. So they should be removed before. URLs and HTML tags should also be removed. They do not provide much information, but if you need them, you can just do the same thing as we said before. You can just include them in another column of the data frame or export to some other data frame or other file. Mentions and hashtags, those are very common in our data set, and they must be removed because they don't provide any important information about the text. But again, if needed, they can be extracted and saved in another column of the data set. But it's important, the same way that emails are supposed to be removed before the special characters, mentions and hashtags should as well be removed before the special characters. Otherwise, we won't have a hashtag anymore. We'll have a word, and it will be included in our comment, that word, and it's usually a mention or a hashtag for something and does not provide any more meaning for this comment. So we got to the stop words. Stop words are a very important topic because they are very controversial, and usually we don't know if we should keep them or not keep them. So it's a very broad subject. So they are usually common words or irrelevant words to our analysis, and some words are more usually considered stop words. For example, the, this, a, and, for, the prepositions, those are usually common words. But I would like to say that usually we should always try to customize our set of stop words. And why is that? Because for specific analysis, words can be important and they should not be left outside the analysis. Let's say that we have the comments of a class that is talking about their grades in their last exam, and they are talking about A, B, C, D's grades. And so we should never include A as a stop word, because if we include A as a stop word, it will be removed from our comment, and we will miss important information. So usually we should customize our set of stop words and remove those customized words. For example, it's sometimes we don't need those words, but if you need for your analysis, don't take them out or create a new set of stop words. So Python have many packages with stop words. You should always pick or create one set of stop words based on your analysis need. So now we get to the numbers. Should numbers be removed or should be kept in our comments? So sometimes they can be removed or they can be converted to a word. If they are important, we should always convert them. If they're not, we should remove them. It depends on the context of your analysis. For example, if we are analyzing some text with the rank of an award and the numbers are removed, we do not know the level of importance of each winner and we miss important information. We should convert all the words to lowercase. And it is because if we don't convert them all to lowercase, we'll have different words, the same word written in two or more different ways. And we'll generate different vectors for words that are actually the same, but they were written in a different format. So that's why it's important to put everything in lowercase, and especially because some other cleaning steps need to have those words in lowercase. For example, when we are removing stop words, they only recognize the words that are exactly the same, and stop words, the set of stop words, are all in lowercase. Also, we convert the contracted words to its expanded form. All the words like can't, don't, it's should be replaced for its expanded form. It is, cannot, do not. Another step in the text processing process is to convert the inflected words to their root. This is important so we don't have different verb tenses or words with the same meaning but written in different manners because they are in plural or singular. And we have two different methods to do this conversion. One is called lemmatization and provides actually the words, and the other one is the stemming that we have the root of the word. So for lemmatization, we'll generate an actual word from which the inflected word was generated. For example, changing will be converted to change. Changes will be converted to change. Different than stemming, because stemming will get the root of the word. And for example, for change, it will convert to change without the E, like it will be change and not change, and that changes the word. So stemming is less computational expensive than lemmatization because the lemmatizing process considers the context and converts a word to its meaningful base form, because change does not mean anything, but change means something, and we need the words with meaning. So in that way, we usually use lemmatization, except if it's very large data set and you do not need like specifics of the words, and change would be sufficient for you. Another step that is very important in text processing is the tokenize. So tokenize splits the word into tokens. If we did not clean the text before tokenize, we will have tokens of every instance of a text, including punctuation signs. So tokenize is usually the last thing we should do with our text before applying a word embedding technique. However, we have to analyze when is best time to tokenize. Parsing words are more computational expensive than phrases or comments because they are smaller and consequently they present a larger amount. This is one of the things that we have to consider when we are deciding in which part of the processing process the tokenization should be done. We can tokenize a text to words or to phrases. In our case, we will be dealing with comments. So each line of our data frame will be a comment. And the most effective way is to text process all the comments before tokenize them into words. At the end, each line will still contain a comment, but only the words separated by tokens. So they will be only tokens in one comment. We have an example here. This is a sample. When we tokenize, we have 4 different tokens. This is a sample. To summarize, clean all the data. That is the first thing we must do after retrieving our data. The next video will go over some code with examples of how to perform this text processing process. And we'll be able to put in practice everything that we saw now in theory. Here we have some references if you need any more detail about anything. We also have in our page of the web courses some web resources that you can go over if you need. Otherwise, if you have any other questions, please feel free to talk to me, send me a message, and I see you in the next video. Bye-bye!